So in this video, we are looking at notes 3, 4, and I'm on page 183. So I'm actually starting with the Explore It. So page 183. It says Eric wants to buy a new mountain bike that costs $250. He's already saved $120, and he plans to save $20 each week from the money he earns for mowing lawns. He thinks that he will have saved enough money after 7 weeks. So they've set up the table here, complete the table. The money saved, we're starting, before we even start putting money away each week, we already have 120 in our account. And that's going to be your y-intercept as well. When x is 0, whatever that number is for y is your y-intercept. Now we're going to add 20 to the account after 1 week, so we'd be at 140, and then 160, and then 180, that's after week 3. And we can extend this out. The question is, do you think he will have saved enough money after 7 weeks? We'll talk about that when we come into class together. We also can graph the data. So 0, 120. We gotta be careful because this is actually counting by 30s, which is kind of confusing. This would be 30 and then 60 and then 90, and we're only increasing by 20s each time. So over 1 up 140, which is going to be a little less than 150, and then over 2 up 160, which is going to be a little more, over 3 up 180. Okay, we can see that this is a linear equation. It says, how can you tell if the relationship is a linear function from the table? How can you tell from the graph? Well, let's start with the graph. Why do we know this is linear? It's a straight line. How do we know from the table? If we look at the table, we know that this is linear because if we look at what everything is changing by, we're increasing by what we call that constant rate. The y's are increasing by 20 each time, and the x's are increasing by 1. So increasing by a constant rate. Remember, what I get written down, please write down on your paper. Let's go ahead, skipping example 1 and 2. I'm going straight to example 3. I want to talk about what this is, and then we're going to go ahead and look at the try it. So if we take a look here at example 3, kind of a real life relationship here. It's talking about the height of a candle. So here we have the height of a candle. It looks like the beginning height of that candle, or that initial height, is 10 inches. Well, what happens to candles as we burn them? As we burn the candle, the size of the candle or the height of the candle is going down. Okay, so that 10 would be your y-intercept, the beginning value, how tall it began. Okay, and then since this one is going down, it's decreasing, our slope is negative. Okay, and they found that the slope is decreasing by 1 inch per hour. So that slope there is, that would be the -1, and it's 1 inch per hour. Let's go ahead and look at the try it together. They give you a graph on the try it. It says the relationship between the number of pages printed and the time. Okay, now it looks like they tell us here that the printer has to warm up. So we have a warm-up time. Okay, well, how long does it take the printer to warm up? Well, that would be your beginning value. It's going to take 1 minute for the printer to warm up. So if we think of our equation here, my beginning value is going to be a 1. It's going to take 1 minute to warm up. And then we just need to find our slope. How many pages are printed? What is that constant rate of change? We know it's going to be constant because it's a straight line. Okay, so we want to take those 2 points. I see 10, 2. Looks like a good point, and 34. If we label them x, y, I'm going to start with 4 minus 2 over 30 minus 10, we get 2/20ths, also known as, we can simplify to 1/10. So every 1 minute, 10 pages are printed. Every 1 minute, 10 pages are printed. So that would be our formula. Let's go ahead. As we have a poster of this in our room, and as we continue to talk about this, we've got to memorize it, that m is the slope, constant rate of change, and b is your y-intercept, or that initial beginning value. That's it. We'll practice in class.